Diablo, Starfield, Cyberpunk, Fallout. There's one thing all these games have in common, and that's abilities, stats, and status effects. By the end of this video, you'll be able to use the gameplay ability system to do exactly that. So before we go down this rabbit hole and figure out how the ability system works, I wanted to show you what we'd actually be producing. By the end of this video, we'll have two characters moving around, both using melee attacks through their abilities, both having a health attribute which can be modified by the attack. Stay tuned and I'll show you how to make the abilities and the effects and the attributes for all of this. But before we start writing any code, I want to go over some of these high-level concepts that the ability system has, just so we are all on the same page and we understand what everything's doing. Firstly, we have attributes. These are basically a float under the hood, which is just a number. They are modified by gameplay effects. To tie this to something in Diablo, the amount of health the character has would be an attribute. You then have attribute sets. These can contain one or many attributes. You can also then define logic inside these attribute sets that manage how those attributes are modified. Going back to Diablo, a character's attribute set might be made up of multiple individual attributes. For example, the health, the movement speed, the mana. Next up we have gameplay tags. These weren't really implemented for the gameplay ability system, but the gameplay ability system makes heavy use of them. An example of it would be status.negative.onFire. They are really lightweight and they can be defined in both data and native code. Then we have gameplay cues. They are usually pretty simple blueprints. They are only for cosmetic use. Do not put any gameplay in these. And they are referenced by a gameplay tag. This is how you will both add and remove them. For example, a gameplay cue might be responsible for changing the shader on a character when they're on fire. Next we have gameplay effects. These are one of the heavy lifting classes within the ability system. They're defined in blueprints. They define which attributes to modify, along with whatever requirements they have. They can set durations, or they could be infinite or instant. You can also add or remove gameplay tags from an ability system, along with any gameplay cues that we want to add whilst this effect is active. It can also define stacking rules. For example, how many stacks of this effect we're allowed to have on any one target. Ability tasks, think of them as Lego blocks that gameplay abilities make use of. These are a specialized form of the gameplay tasks. They are for asynchronous execution of code, usually written in native, but you can do this in Blueprint too. Within the ability task, you would define delegates. These delegates would then help control execution flow within a gameplay ability. And they are explicitly tied to the life cycle of a gameplay ability. So when the gameplay ability ends, it cleans up after itself. Now we have gameplay abilities. These are the bulk of what you're going to be working with in terms of the ability system. They are primarily made in blueprints, though you can do them in native. I would recommend not. It will make use of all of those Lego blocks we defined earlier to then create an interaction that we want within the environment. They can have requirements in order to run. For example, a specific gameplay tag has to be on a character before they're allowed to use it. They can also have cooldowns. So for example, if I have recently used the ability, I can tell it to apply a gameplay effect, and when that gameplay effect ends, I'm allowed to reuse the ability. So lastly, we have the ability system component itself. This is an actor component which can be applied to any actor in the scene. This contains the abilities and the attributes. It'll be used as a target for all interactions. So that's a kind of high-level overview of all the ability system components. There's far more detail in the actual components themselves, but I just wanted to give you a really quick overview of what each of these pieces do, so when I mention them, it's not completely out of the blue. Now, in order to make use of the gameplay ability system in your project, there's a few things you're going to need to do. Jump over to Unreal and open your plugins folder. Here you want to search for the Gameplay Abilities plugin and just tick the box next to it to enable it. Alternatively, you can boot up your IDE, find your .u project, and add the Gameplay Abilities plugin to your plugins section and set it to enabled. We also want to go into the build.cs for your project, and even the public or private dependency modules, make sure you add Gameplay Abilities. So now we want to create our first attribute set. In this case, we're going to have a standard attribute set that all of our characters are going to make use of. We define an attribute by using the fGameplayAttributeData struct. We also want this to be a U property. You may notice we have attribute accessors. This is a combination of 4 macros that are built into the gameplay ability system. This is to get the property itself, defining a getter and setter for the values, and also initializing the property. When it comes to a character attribute set, I tend to define a health max, and a damage. This damage is going to be a meta attribute. All of our gameplay effects will apply damage to the character, and then that will be removed from the health. We will then add some logic to stop the health from going below 0 and also going above health max. So we want to override the PreAttributeChange function that comes with the attribute set. This will be called whenever an effect modifies an attribute. In this case, we want to ensure that the health attribute never goes above the health max value and it never goes below 0. So the reason I have a damage attribute is mostly for future proofing. For example, if all the gameplay effects are adding damage via the damage attribute instead of modifying the health attribute directly, we can change what that calculation does in the future. So let's go into what the PostGameplayEffectExecute does. This is called every time a gameplay effect is applied to the ability system which controls this attribute set. As you can see here, we check to see if the damage attribute is the one that's being evaluated. If it is, then we store the damage value because it's already been set. We then reset it back to 0 because we don't want to keep that persisting. So if the amount of damage done is greater than 0, we now want to modify the health and set it. That way we have damage applied via the damage attribute. And if we wanted to extend this in the future, we could change the calculation here. Now, as I mentioned, the damage attribute is server-side only. This means that we're not replicating it at all. The health and health max are replicated, and they're replicated using their own functions. We've defined them here, so let's just go into them very quickly. We use this macro GameplayAttribute_rep_notify. This tells the underlying ability system, which contains this attribute set, that the attribute has been modified. Without this function, the ability system would be unaware of any replicated value changes, so it's very important that we have this. So now that we've created an attribute set, we can actually start creating gameplay effects that can modify those attribute sets. We've created here a blueprint class. I just right-click blueprint class, type in gameplay effect, and then press the gameplay effect, select. The naming convention for gameplay effects is GE, so GE_demo in this case. So you see on the right side here, we have duration policy. This could be instant, infinite, or has duration. If you set it to has duration, duration magnitude will be visible. You'll be able to set a value here, which will define how long the gameplay effect is active for. Next up, we have modifiers. These are attributes that the gameplay effect modifies. Created the first array element. We'll notice it says attribute here. We need to choose the attribute that we want. In this case, if we're making a damage effect, we would set it to the standard attribute set.damage and the magnifier op to add. There are multiple magnifier ops. For example, if you wanted to half the amount of health a character has, you could go to health, divide, and type 0.5. But in this case, let's just do a simple damage. We're going to just simply add 5 damage to the character. Now, each of these modifiers, you can require both the source and the target to have certain tags. For example, if you wanted to make it so you could not apply damage to a character if they have an invulnerable tag, you would go to the target tags, ignore tags, and then set the specific tag you would like. So both the source and target tags have require and ignore. If a tag is required, then the target or the source will have to have that gameplay tag applied to them. If an ignore tag is set, then an ability system must not have any of the tags defined. Gameplay effect executions are slightly out of scope for this tutorial. They're a somewhat more advanced feature of gameplay effects, but I will cover them in a future video. Conditional gameplay effects allow you to add additional effects if the current effect applies to a target. So for example, if this effect applies correctly to a character, I may want to also make it do a slow effect, so I would add a slow here. If you have a duration policy set to has duration, you'll notice that there is a period value here. This is similar to a dot effect. If the period is set to 1, then every single modifier will be fired every 1 second. Under the tags section, you may see that there's a bunch of different options here. I'll go for each one. Okay, so to start with, the gameplay effect asset tag, you can apply a single tag to this gameplay effect itself. This makes it easier for querying later. The granted tags allow you to add individual gameplay tags to a target. As long as this gameplay effect is active on a target, they will have the gameplay tags defined here. You can also set tags for abilities that you wish to block. If the gameplay effect has a duration, you may want to use the ongoing tag requirement. An ongoing tag requirement is something that will be used to determine if a gameplay effect is on or off. Treat it like a suppression. If I have a gameplay effect that buffs my character in some way, but I want it to be suppressed if they have a stun applied to them, they can have an ignore tag set for status.stun, for example. And if I have that tag, this effect will not be applied. But the moment that tag is removed, the gameplay effect will come back. Application tag requirements are tags that must be set on the ability system which has this effect applied to it. For example, if I wanted to apply a buff to a character, if I required the target to be alive for a buff to work, I could set the require tags to status.alive, and then the character would have to have that tag in order for it to apply. The inverse is true with ignore tags, so the tag cannot be present. So removal tag requirements function similar to how the application tag requirements do, but if that tag is ever applied to a target, it will remove the gameplay effect immediately. Lastly, we have remove gameplay effect query and remove gameplay effects with tags. These function very similar to one another. I'll just go over the tags one for now. If, for example, you wanted to remove another gameplay effect from a character, you could specify the tag here. It will check the gameplay effect asset tags on all of the gameplay effects applied to a target. If any of them match, it will remove that effect. Next, we have the granted application immunity tags. So for example, if you wanted to make yourself immune to crowd control, you could set the tag here to status.crowdcontrol, and any tag with the gameplay effect asset tag of crowd control would automatically fail to be applied because you have immunity to it. Next, we have the stacking type. By default, this is set to none, which means that every single instance of a gameplay effect is treated as an individual instance of it. If you set it to aggregate by source or aggregate by target, it will count them together as a single instance, and you can put limits on how high that stack can go. The stacking type can be set to aggregate by source or aggregate by target. If I wanted to make sure that my own character could only ever be affected by 5 instances of a specific type of gameplay effect, I could aggregate by target. If I wanted it to have the caster can only have 5 active at any one time, it would aggregate by source. There is a duration refresh policy, which can be set to various things. Same with the period reset and the stack expiration policy. You can also set a stack limit. By default, this is 0, but you can set it to any number you wish. And lastly, we have granted abilities. These are abilities that are granted whilst this effect is active, and they will be removed when this effect is removed. You'll notice the gameplay effects themselves have no blueprint functions. They are purely data assets. So for a real-world example of a gameplay effect, we have GE_initial character stats. This has an instant application, so its duration is instant. It sets the health max and the health attribute to 100 by setting the modifier op to add and setting the magnitude calculation type to scalable float and the scalable float to 100. So now we've created our attribute set, we want our character to make use of it. We also want to give it an ability system component so it knows how to interact with the world. So to do this, we're going to create 2 properties on the character itself. They are both U properties. One of them is going to be the ability system component itself, and the other is going to be a standard attribute set, the thing we just created. So in order for ability systems to interact with one another, they need to have a common interface. This is called the AbilitySystemInterface. We just want to implement this. Quite a simple function. All we have to do here is just return the AbilitySystemComponent property that we just created. Now, in the character's constructor, we want to create 2 sub-objects. One is the AbilitySystemComponent, one is the attribute set. Because these are both actor components under the hood, they will just attach directly to the character. Now, the next thing we want to do is on begin play, we want to set up its initial abilities and effects. So the initial effects will be things that set the initial health state of the character. So in this case, I'm going to set the health to 100 and the max health to 100. So I've created this function here, set up initial abilities and effects. Within this function, I use an initial gameplay effect. I've just created a subclass of a U gameplay effect and made it a property on the character. Now, using the ability system component, I can now apply that effect directly to itself. Now we also want to add abilities to the character. To do this, I've created this initial ability set. Now I've also made this UAbilitySet class. This is quite a simple class, but it's very powerful. It allows us to define a group of abilities with their input bindings. It's just a U data asset, which means that we can define everything in data. It's just an array of gameplay abilities. So we just store the class of the gameplay ability we want to use. We then also take in the input key that we want it to be bound to. In this case, I've made an enum, jump, primary, secondary attack. The ability set class also has a function called grant abilities to ability system. Within this function, we pass in the ability system component that we created earlier. We then go over all the abilities that we defined in this data asset. We then give those abilities directly to that ability system, whilst also binding the input ID that we've defined. The input ID is just an integer. In our case, we've defined it in an enum, but you could just hard code this to whatever numbers you want. I would recommend using an enum for ease of use later down the line. As you can see in this setup initial abilities and effects function, we're just telling it to grant the abilities via that function we just created. It allows us to completely data drive our initial abilities and the effects. And lastly, we have our input bindings. This is just a bridge between the enhanced input system and the gameplay ability input. This is done by a simple array. We just pass in the input actions, and then we also pass in the enum variable that we want. And then on the actual setting up of the player input component, we're setting the triggered and the complete events. We're then passing in the input ID. The handler is then going to fire ability local input pressed, or the ability input that we've just passed in. It sounds like a lot, but in the input bindings for your character, whenever we press the key bound for this, it will activate the ability bound to this. For the initial character abilities, you can see how we've bound the jump ability to the jump key, the melee attack ability to the primary attack, and the melee block to the secondary attack. Okay, so now let's create an ability. In this case, we have GA_melee_attack. This was created by right-clicking, going to gameplay, gameplay ability blueprint, and then deriving from gameplay ability. This ability itself has no ability tags. It doesn't cancel anything, it doesn't block anything, it doesn't have any owned or any other tags. I'll go through that in a second. But this is quite a simple ability. It plays a montage and waits for it to finish. And when it finishes, it ends the ability. Whilst this montage is playing, it also waits for a gameplay event called event.melee.attack. It will only trigger once, and then when that event is received, it will collect the target data by using this wait target data node. There are various targeting systems that you can use with the gameplay ability system. In this case, I just chose a really simple one, which is just doing a radius check. So the way this targeting system works, it grabs everything around a location within a certain radius. We are just grabbing the character's location, setting it forward slightly, passing that into the targeting data, and because its confirmation type is set to instant, it will instantly return and then jump into this valid data or cancelled. If it has valid data, what it will do is get all of the actors from the target data that's returned, iterate over them, try and get their ability system component. Under the hood, this is calling that interface that we defined earlier. It checks to see that it's not applying damage to itself. If all that passes, it makes an outgoing gameplay effect spec based off of a standard damage class, which we've defined here. The way the standard damage works, it just has an instant duration policy. It just sets the standard attribute sets damage variable to whatever is set by the caller. Magnitude calculation type is set by caller, and the data tag is a set by caller .damage amount. By making an outgoing gameplay effect spec, we can now assign that caller magnitude. In this case, we're setting it to 10. And then finally, we call apply gameplay effect spec to target. This is a function on the ability system component. We're using the owner's ability system component to target the target's ability system component and then applying that spec to it. I mentioned in the past we have these ability tasks. They're kind of like Lego blocks. You can see how quickly you can put them together to get designers building functionality within a game very quickly. And because they're all native code under the hood, they're relatively fast. Now that's not to say you can't make really inefficient blueprints with gameplay abilities, but they should all roughly be around this size. Very rarely do you want to have a humongous, long-lived gameplay ability. Now, I previously mentioned you have these properties that come with the gameplay abilities themselves. So ability tags, cancelling abilities, etc. Let's just quickly go over each one of these. So ability tags are similar to the gameplay effect asset tags. These are tags that are applied directly to this gameplay ability. It makes it easy in the future for searching for things. For example, cancelling abilities with tags. We'll check to see if you have any abilities that match that tag. Moving on, we have cancelling abilities with tag and blocking abilities with tags. What cancel abilities with tags does, it checks to see if you have any abilities that are currently active, and if they are, do they have any ability tags that match? If they do, they are cancelled immediately. Block abilities with tags is similar. It checks to see if the ability has any tags when they're activated, and if they match, they are blocked from running. Activation own tags adds gameplay tags to the ability system that's controlling this ability. So once this ability is activated, it will grant certain tags. Activation required tags, they simply are tags that are required on the ability system in order for this ability to function. If it doesn't exist, it won't run. Activation block tags is the inverse of that. Activation block tags requires that the ability system does not have a certain tag listed here. Next, we have replication policies. This is for multiplayer. If you are going to be making multiplayer games, some abilities you may want to have replicated. We will talk about network replication in the future, and we'll go over how this works with gameplay abilities. Next up is instancing policy. There are multiple policies. I tend to use instance per actor. This means that there's one single ability per character that's using it. Instance per execution creates an individual ability per instance of that being activated. I don't recommend that because it's quite because you end up having quite a few. I've never used non-instance, but I can see cases where you may want to use that. Next, you have server respects remote ability cancellation. Again, this is for replication. If you cancel the ability locally, the server should also cancel the ability. And then you have retrigger instance ability. And then you have net execution policy. By default, this is locally predicted. Sometimes you may want to have this to server only or local only. We'll go into this in detail in a future video with network prediction and replication on gameplay abilities. There's also a network security policy. Again, we'll go over that in the future. This cost gameplay effect class, think of this like mana in Diablo. You can apply a gameplay effect as a cost of using this ability. The same with cooldowns. So cooldown gameplay effect class, this is a cooldown that you can add, which is normally a specific gameplay effect that has a duration of some kind and a tag. It checks to see if that tag is still on the character, and if it has that tag, it's unable to use the ability anymore. until that tag expires. And then you also have ability triggers. There are multiple ways to activate an ability. The one we are using so far is just triggering via input. So whenever we press a key, like in this example, left mouse button, whenever we press that, it will activate the ability. For example, if I had a tag added to my ability system and I had an ability that was waiting for that tag to be added, I could have it activate immediately upon that tag being given to me. I could also have it triggered based off of a gameplay event. Gameplay events are basically just gameplay tags that have additional data associated with them. As you can see here, we're using it for the melee attack. The melee attack itself, in the animation montage, I've defined an animation notify. So you see this position here. This is an animation notify. In the blueprint for this, I just get the owner and then I pass the gameplay event that I want it to fire. In this case, I've set the gameplay event tag to event.melee.attack, which means that the moment that this point in the montage is reached, it sends that event. That event is then picked up by this node here. Lastly, we have source required tags and source blocked, target required tags and target blocked. These are only ever used when triggered via gameplay events. So if you set a trigger source of gameplay event and pass in optional targets or optional sources, it will check the tags on those assets here. Now you'll see if I hit the left click, the ability is playing on both characters, even though it's networked. And the health is also modified if I left click. So that's the gameplay ability system set up and running. So this is a very high level look at what the gameplay ability system can do. There's a lot more detail in the future that I want to go over, but for now I want to leave it here. So if this video has been helpful for you, if you could both like and subscribe, it would be really helpful for me to grow the channel. Anyway, thank you very much and I hope this has helped. Take care. See you later.